All right, with the end of Unit 2, we've got to talk about the most current atomic models, starting with the Bohr model. And this is Niels Bohr's contribution to the atomic model. And he coined the term electron orbital and studied how the electrons surround the nucleus. So the last model we talked about was Rutherford's model, where he said that there was a dense nucleus in the center, a bunch of empty space, and then the electrons. His idea was that the electrons were just in like one circle around the nucleus. Bohr expanded that. All right, so Bohr is, you might recognize one of the gentlemen in this photo, probably this guy. If he didn't have his hat on and you could see his crazy hair better, you'd recognize him as Einstein. And then this is Niels Bohr. All right. So he determined that there's actually more than one location for the electrons surrounding the nucleus. And he described it as orbitals, or like planets rotating the sun. All right, so you've got these different circular levels of where electrons can exist, and they orbit the nucleus in those levels. All right. A key term to be aware of related to this is the electrons on the very outside, on the outermost orbital. So that would be, these guys out here in this outer circle. We call those valence electrons. We're going to talk about those in much more detail coming up, but those are the electrons on the outermost level, and they are the ones involved in bonding. So, according to Bohr's model, there were concentric rings of orbitals, and then there was a specific number of electrons that could fit in each one. All right, so like the very first orbital could only hold 2 electrons, right? And then the next orbital could hold up to 8 electrons. All right, so for example, this happens to be a nitrogen atom, which has 7 protons and 7 electrons. So you can see there's 1, 2 in the first one, and then 3, 4, 5, 6, 7, or a total of 5 in the second orbital, and then it stops. Right? So you don't have to have 8 in there. 8 is just the maximum. If you went deeper into the periodic table and there are more electrons, the third level could hold 18, fourth level would hold even more, and so forth. So, in general, as you move farther from the nucleus, the orbitals hold more or fewer electrons. Hopefully you said more, right? That's what we saw on the last page. It went from 2 to 8 to 18, right? So as you go further from the nucleus, more electrons can be there. Makes sense, the circles get bigger. All right? Now the interesting thing is how Bohr and other scientists discovered this. And what they did was they energized, vibrated the electrons, put some energy into it, and saw that light was given off. All right. So what happened is as you energize these electrons, you're changing the energy that they have. So electrons that are close to the nucleus have low energies, right? And then the farther away from the nucleus you get, the more energy those electrons have, right? You can kind of think of this in a couple of different ways. One, the closer to the nucleus, those negative electrons are going to have a stronger attraction with those positive protons. So the protons are going to be able to hold them still better. They'll have less energy. All right? You can also think that in order for the electrons farther away to be able to pull away, to be able to, get away from that attraction, they have to have more energy. All right? So the closer to the protons, the less energy the electrons have. The more likely they're going to just stay where they are. And then the farther away, the higher the energy they have and the easier time they have moving around. So, Bohr talked about the electrons in 2 different ways. There's your ground state electron, all right, or these are where all electrons are at their lowest possible energy level. And then there were the excited electrons, the ones where we've put some energy into it. We've bumped them up an extra energy level. All right, so an excited electron is higher than it would be in ground state. All right, it's been pushed to an outer level. All right, so they've been excited. They've been given extra energy so that they can move around and get away from the center. So there's Bohr's model.